don't think Juergen needs any introduction, but I'll let him introduce himself briefly.
Yeah, a different personality of mine. Yeah, aside from all the Spring Framework focus that I tend to have, I also am a bit of a Java EE stakeholder within SpringSource, right? So I'm actually, over the years, I'm spending a lot of time with the iterations in EE and how Spring could possibly interact with those. So this is a topic that's quite dear to my everyday work next to Spring Framework. And, well, Marius?
Thank you. My name is Marius Bogoevici. I work for JBoss, or RedHat. I'm leading a Spring integration project there. Basically, a project that builds a series of utilities on top of the JBoss application server for Spring applications. I'm also involved in various Spring-related initiatives at JBoss. So basically, again, for me too, this is actually a topic that's very, very interesting because we encounter every day this particular situation, right? And it's basically what we're going to focus today, essentially, is a very simple thing. You have a Spring application that runs in a Java EE environment. And we're going to try to see what services are available, what options do you have. We're going to try to see what the trade-offs are. We're going to see how can you actually try to optimize the way the application works, right?
Yeah, some of this is certainly well known among actual Spring on Java EE users, but some of those options are actually not as well known, right? There are some variations that you may not be as familiar with. But let's maybe check quickly, who is actually working with Spring in a Java EE environment here in the room? All right. Who's of those? Who is working with Spring in a Java EE6 environment? Okay. Who's working with Spring in a Java EE5 environment at the moment? That leaves a couple of hands. So, of the rest, who's working with Spring on a J2E 1.4 server? Is that still? Okay. Well,
lucky you.
Yeah, that's ending rather soon, I suppose. The J2E 1.4 remains. All right. This is basically what we're going to talk about, right? And we're going to dive into a couple of further topics along the road, including Achillean integration testing in container and a little bit of CDI Spring integration towards the very end.
Right, to see how how Spring and Java EE programming model can coexist. So I think the starting point, like one of the things that we want kind of to clarify in this talk is the relationship between programming models and services. And especially this is something that's needed when you look at, for example, the Java EE as a specification. Java EE doesn't make it very clear where the boundary between platform services and programming model is. Obviously, there are some specifications that describe what can the platform do for you. Things like JDBC, for example, or JMS, or JDA, right? These are things that tell you this is what the server provides. On the other hand, you have the programming model, which tells you how should you write an application, right? And this is where you have things like CDI, JXRS, EJB. And it's worth mentioning here that this is not always a real boundary. It's more like a conceptual distinction. Take, for example, JPA, which basically describes you how to write entities, but also describes you what the contract between the container and your deployment unit is in terms of actually getting a persistence unit bootstrap, right? And I think one of the things that we are going to focus more in this discussion from a Java EE perspective, what we are looking at is really the services part, right?
There are a couple of, the boundary really isn't very, very clear, right, in some cases, but I suppose you've noticed some of those, right? The services that you tend to access, even on Tomcat, like a managed data source, any managed Chindi resources, that's really a platform service of the traditional kind, right? You obtain it and you just refer to it and call into it. And the APIs of those services, they are basically, quite independent from your application's code. They don't refer to application classes. You pass in SQL strings or messages or whatever, right? Whereas JPA, it's a service that manages your persistent entities. It's a different kind already. And if you dive into GSF or CDI, it's really a model that you use for programming your own components, right? So quite different services.
Yes. And I think that probably we would, like looking at the other part, like the Spring.
Yeah, from a Spring perspective, I mean, that's our good old triangle, right? I suppose most of you have seen it a number of times over the years, and even at this show. But Spring always had a quite strong focus on the portable service abstractions. Next to, of course, dependency injection and aspect orientation, it was always about access to services that the environment would provide to the application. Those service abstractions basically have two different categories of backends. It could be services that the server itself provides, comes with, exposes to the application, or it could be embedded services that you include within your application that adhere to the same, conventions, to the same service interfaces. Basically think about embedding a persistence provider as opposed to obtaining it from the server, or even embedding a connection pool, a data source implementation within your application as opposed to obtaining it from the server's naming system. So we're basically talking about a pretty central part in Spring, the area where the framework basically takes your components, your programming model, your application's architecture, and kind of makes sure that it sits nicely on top of the environment, but also within the environment's service arrangement. So that was a pretty strong focus in Spring. It still is, and we're going to dive into a couple of services to exemplify this in a moment.
And just like when you look at this from the platform services programming model perspective, the first two sides of the triangle are really what makes the programming model. As Juergen said, it's platform independent, it reflects business concepts, it's oblivious of infrastructure, and basically reuses the portal service abstractions. And really, this is what you know, this is what you see while you're developing. 99%, you don't really care too much about portable service abstractions while you are developing your application. That's actually a very good thing. It's one of the strengths of the Spring framework, as Juergen said. You can always swap between different implementations. Where we look at the services, where services become relevant for the discussion, is when we look at operations, when you look at what happens in production. So essentially, you spend very, very little time here. We just define them, but you actually spend almost all your time while your application is running. And as you will see, the discussion, the theme of the fact that this is like particular services have benefits when used in production while your application is running, will come back and back again, right? Which brings us to the question, how do we actually picture this as a whole, right? Oh.
Well, this is basically just an illustration, right? There are many services that can be referred to, but in terms of taking standard services, the obvious ones are JDBC, JMS, even JPA and JTA to refer to the Service Transaction Manager. There's more that you can do with Spring, of course. You can expose Spring Managed Beans as mbeans, where you're integrating with an mbean server that in an application server environment is a platform service as well. It may run, all of this may work in non-managed environments too. But if you're running on an application server, you actually want to use the server's mbean server, you want to use the server's JDBC data sources, because the server, an application server, what is it there for? It's supposed to manage resources efficiently, so it's also supposed to know about what's going on with those resources. So there are quite a few reasons why a server provides those services, why you wouldn't embed them within the application. And well, there's a choice of servers, obviously, over there in the right-hand corner.
Right.
You know those guys, right? WebLogic, WebSphere, JBoss ES, Glassfish, of course. We traditionally had a quite strong focus on, well, the initial crowd of J2E servers back in the day, right? WebSphere and WebLogic. These days, it's a bit of a different arrangement because if you look at like Glassfish or JBoss, they obviously implement more recent versions of the spec more quickly, or at least they tend to. So it's a bit of a different arrangement over the years. Spring has a tradition of adopting those more recent EE developments very quickly. So if you think about Spring 3.0, was actually released a couple of days after the Java EE6 spec went final. So Spring was among the very first frameworks supporting EE6 level specifications, such as JPA 2.0, GSR 330, GSR 303. So those specs really matter to what Spring is doing. And recent server generations are an important reference point for Spring. So we're really ambitious about supporting those servers in the latest incarnations. We even go a little bit beyond by having server-specific support in a couple of cases, right? Exactly. Where the specs have gaps, task execution, asynchronous task execution. We ship specific support for JBoss, for Glassfish, for WebSphere, for WebLogic. So we even have a little bit of server-specific support in there beyond the specs. Most people know that we're doing this, but one tends to forget that it is necessary in some cases. We go that extra mile if necessary.
Yeah.
Transaction managers too. Thank you, Josh. Even in areas as central as transaction management, service-specific support is sometimes necessary.
This is what actually makes the discussion so interesting in this context, right? Now the question is, what services do you want, like what services can you use, and what are the benefits of actually using them, right? So I think we picked up the, let's say, the most used, the most popular, the most typical Java EE services that you can use in your application, and we'll go through, as I said, through the various trade-offs and benefits and options when you're using them. So I think nothing gets more basic than the data source, right? Getting one of the most, as I said, basic functionalities of an application server is to deploy some managed data sources. And even Tomcat does it. It doesn't even have to be a full-fledged Java application server. Even in Tomcat, you have the option of creating a managed data source and retrieving it from the application server, normally through a GIND-based mechanism, right? So basically, where does it matter? What does it add, for example, on top of, I don't know, deploying embedding the data source inside your application, which obviously makes things more flexible? Well, it helps in a few places. Operations. If your server has good monitoring and data, monitoring and management capabilities, it's definitely going to help because you get access, you get all the information about the way your data source behaves. Also, for management, it's very easy to, for example, to point your application server to a different database, to manage it separately from your application deployment, right? This is particularly important if you have an application server with a central managed domain. So basically, if you have a massive cluster and you want to basically update each instance with a reference to the correct data source, it's really easy if you do it centrally and basically propagate it to all the clients, right? And a few application servers support this, right? I think JBoss AS7 surely does, WebSphere does, and I think WebLogic does it too, but I'm not sure. Anyway, in this environment, it is like management and monitoring is probably one of the more powerful options.
Well, one note to add here is with JDBC data sources, you can treat them quite independently. basically, it's just about outsourcing your connection pool basically to the app server, right? That's quite independent from transaction management decisions. So if you end up using local native resource transactions in your Spring-based app, you can happily do so against a server-provided connection pool, a server-provided data source, as long as it's configured appropriately. Exactly. Sometimes it's a checkbox like support local transactions on web server. But it's all doable. It's actually pretty common. That combination is pretty common. Spring-managed local resource transactions against server-managed connection pools. So there are different ways to combine those services, and usually there are ways to independently decide on those characteristics.
Exactly, and I think one of the the restriction works only one way. If you want to use JTA, you have to use a managed data source. If you use a managed data source and you configure it properly, as Juergen said, you can use whatever transaction strategy you want. Again, it's very simple to access. Like from a programming model perspective, you really get through the Java EE Jindy lookup support, you really get a data source instance. You don't care where it came from. You don't care what it did. You just inject it in your application and you run with it. It's very, very simple. Which brings us to the next, and probably one of the discussions that has probably the potential of going the longest, transactions. I think you can have an entire presentation only on transactions.
Which I actually did before.
Which you did.
Yeah.
I've been into that. I've been into that presentation. Very good. So, yeah.
Well, let's start with the most obvious fact, right? JTA is within the Java EE umbrella, the Java Transaction API. So a pretty general way of demarcating transactions. However, it has a strong focus on XA, right? So it's actually an interesting combination. It's a general transaction API with a strong focus on a specific transaction protocol. So XA capabilities are pretty central to understanding JTA. That said, at the same time, JTA comes with, it allows for optimizations, to be specific, right? So if you happen to end up using a single resource in a transaction, there are ways where a JTA provider may optimize for what they call basically a single resource and a local transaction on that single resource, which kind of is not that far from a native transaction, but it's not quite the same either. You're still going through the JTA contract, through XA-capable data sources. They just end up to optimize for a single resource case, right? But so that's a pretty common arrangement, using server-managed JTA initiated transactions against a single resource. But in terms of what it can do, its real power is in the multi-resource case.
Exactly. I mean, that's the fundamental strategy. The point is that the support, like the experience that you have using JTA, is as good as the transaction service that actually implements it is. Now, that being said, there are some things like, even if kind of JTA as an API tends to obviate what happens behind the scenes, and some of those things that we are talking about, like local transaction optimization and so on, happen transparently, there are some implications about the even coming from the API in what concerns what you can actually do with these transactions, right? Which allow you to, so you'll have, for example, if you're trying to optimize for read-only operations, for instance, it's a non-trivial feat because the API itself doesn't allow for it, and as I'm sure Juergen can confirm, it's actually you have to go deeper into the provider itself, and this is where the server-specific extensions are coming from to actually do this type of operation.
To some degree, those are inherent limitations coming from the XA capabilities, right? I mean, it's sort of if you're designing a transaction API for XA transactions. XA transactions have a notion of kind of read-only use of a resource, but you only find out basically during a transaction, after the transaction basically had all its resource operations applied. Then you find out that you effectively just did read on a specific resource, and you could optimize a way out of the two-phase commit process, right? So there are some XA-oriented read-only optimizations in JTA, or in that kind of transaction service, to be fair, right? However, there's no way to initially state that anything that you will do within a given transaction will be read-only. There's no way to tell the transaction service, but basically I'm starting a transaction, but hey, all I want is basically a transaction scope, but I'm just going to read, right? I want consistent reads maybe, but I'm not going to do write operations. You can't tell up front. That prevents a number of optimizations. If the service cannot reliably say that it's going to be read-only operations only, it basically has to proceed in a way where it can deal with a write operation coming in anytime. So it's just a natural limitation. If you can't set a read-only flag at the beginning, basically, the service cannot apply certain kinds of optimizations. And you may have run into those, right? If you're working with JDBC, with native JDBC transactions, where you can set a read-only flag, those have strong effects in some scenarios. Think about MySQL clusters, where the read-only flag is actually being used to delegate read operations out to slave nodes. If you don't set it, you'll end up with the master node all the time. In other cases, it's just an optimized way of processing in the database management system, right? Where if the database knows you're just going to read, it basically, well, it doesn't even bother with a transaction log and optimizes certain processing characteristics right away, right? So it's a feature that you can have with native resource transactions if you're using a JDBC-based transaction manager. It's just not there with the XA-oriented model in JTA. So that's a little bit elaborated on the read-only part, but it's pretty important. And it's one of the reasons why Spring's Edge transaction annotation has a read-only flag, because we kind of have supported transaction strategies that do support it. And, well, Edge transaction attribute in EJB, or the upcoming JTA 1.2 Edge transaction version of that annotation, they don't have a read-only flag because they can't do anything with it, right? So that
it's kind of assumed underneath.
Yeah. All right. So that's it's a bit of a subtle topic, but it's pretty important because those optimizations can really make a difference.
It's more about your system. It's really more about what do you want to trade it? What do you want to trade for? What? Do you want the performance, read-only support, and so on and so forth, like this of native transactions? That's fine. There are like, why do we even discuss about JTA? Because it's really like using JTA as your transaction management strategy still makes sense in a lot of situations. How many of you are actually using JTA? Right, quite a few. Why does it actually help? It's for one thing, the transaction context is managed transparently. So that is especially useful if you want to integrate Spring with other components that understand JTA. When I say understand JTA, I mean that they could be EJBs, which are natively JTA oriented, but it can be other frameworks that, for example, rely on transaction synchronization hooks to do their job. They don't even have to be a separate resource, right? It's obviously you have the case where you have multiple resources in your transaction, which is one of the capabilities of JTA and XA, right? But apart from that, you can really have like a single resource, and you can have multiple components just sharing the same transactional context and kind of relying on the local optimization transaction to make sure that there's no performance degradation due to two-phase commit or some other things. The other reason is basically you can get access to the feature of the transaction service. Again, as I said, the experience that you have is as good as the transaction service behind it. So you get management, monitoring for your transactions, performance. You can get the disaster recovery capabilities, which are, again, not something to be neglected if you're in a mission-critical scenario. Now, of course, you can rely on that, like you can rely on those things even for, like even using your database capabilities, if your database is powerful enough to do such things, right? But in a lot of cases, it is the transaction service itself that implements these functionalities. So you get access to it.
In particular for the multi-resource case.
Exactly.
Right?
Yeah.
That's, and if you have more than one resource involved, somebody has to do the coordination between those resources in the transaction. If something goes wrong in flight during the transaction, there has to be a recovery process in some form. And it's actually absolutely non-trivial. It's hard. It's a hard topic. So writing a good XA transaction manager is really, it's a tough job, right? In particular to do it efficiently. Right. There are naive ways of making sure that everything can be recovered, right? But it basically means write every single step that you do, write it to the file system into some transaction log, right? So that you know that you did it. Well, think about the performance effect of that, right? So they're doing it efficiently in a way where there's an efficient transaction log you only write to if you absolutely have to. And recovery basically, kicks in automatically so that it's kind of hidden from you at runtime. It also means that you need good XA-capable drivers, right? So it's about the quality of your transaction manager for sure. It's also about the quality of your XA-capable resource drivers. XA-capable JDBC drivers, XA-capable GMS connection factories. And sometimes that's where things are lacking, right? If you have an XA driver that kind of, is a pseudo XA implementation and on prepare calls coming in during a transaction, it just does nothing, then it's effectively not capable of doing a two-phase commit, of participating in an externally managed two-phase commit, right? So all in all, if you want to do multi-resource transactions, make sure you've got a good transaction manager in place, make sure you've got the right drivers in place for your resources, and test the recovery case, right? Just make your system fail and see whether recovery kicks in. There are too many scenarios where where people just assume it's going to magically happen if something goes wrong. They never actually test it. And there may be a flag that you forgot, right? There may be just something that you forgot that makes recovery break. You'll only find out if you actually test recovery. Start a transaction, kill the process, right?
I think I have a question from
sure,
gentlemen.
What is the best way to know that you have a real optimized driver? We've kind of questioned that for a long time. We're not really sure if we're using the best. It may be a real old driver. I think there's new drivers out there.
So the question is basically, how do you know whether that you're using the best possible drivers, the best possible setup?
It may not be the most optimized one for your
Yeah,
context.
there's no simple answer to that, right? Some of the vendors, like IBM and BA, Oracle now, right, they solved that problem through not only shipping a transaction manager with the application server, but also shipping XA drivers for common databases and common message brokers that they certified within the server, right? So that you know that those things are basically interacting properly. If you're combining a transaction manager with third-party drivers, there's always a risk that something isn't exactly smooth. But other than basically using the latest versions, checking what the supported scenarios are, like each vendor basically certainly tested it with something, right? So making sure that you're using a combination of transaction manager implementations and drivers that kind of have been tested against each other before you combined them. But that's really the only guideline, right? Other than that, it's very specific to the vendors and very specific to the resources.
Even at JBoss, we certify certain databases. So we have kind of a number of databases which are certified. I would say that you will find the most popular ones, definitely. Like,
Our challenge, we're Redsphere, and our challenge is Redsphere is at this, maybe in this version, and our RDE is DD2. So, and they upgrade at different times. So, Redsphere 7 says this is the best driver, but that's only applicable for DD2 9 and 10. But we're still down here, so that's kind of where our challenge is. They're hooking back and forth on each other, we're just trying to find something. We just don't know whether we have to do optimized batch there or not.
Yeah. So I'm just
sometimes
summarizing
it's
it
more
with-
about ask your vendor.
Since yeah,
Well,
there's, you'd better get in touch basically with the vendors in this case. That's the best advice we can give, really. But I'm just summarizing quickly. It's about the combinations of versions. If they upgrade at different times, that's a very common problem. You upgraded one of your parts, basically, like the app server or like the database, and all of a sudden, something in the XA driver arrangement doesn't quite work anymore. And it doesn't necessarily break when you start it up, right? The hardest part is it breaks in some scenarios, like recovery scenarios, right? You'll only find out that it breaks in some specific scenarios that your system runs into. That's one of the reasons why some people don't upgrade their app servers or their databases, right? If they know that they work, just keep them at that version level. It's one of the reasons why operations teams choose to do so, right?
So yeah, I mean, the point that we were trying to make somehow is that even if we, like, given the whole set of considerations that you have to make about the quality of your XA service, there are benefits, and given the whole set of pitfalls and the things that you have to be careful about, right? There are still benefits in doing it in certain scenarios. You have to understand the scenarios. You have to you have to know that what exactly, for example, a multi-resource support brings to you, right? The other point that I would like to emphasize, apart from multi-resource, is that sometimes, as I said, JTA, like even in a single resource scenario, JTA may be a convenient way of actually ensuring that all the components which are participating in this particular, they're participating in a particular transaction, are actually seeing the same transactional context. It's very convenient. We'll probably see about that when we talk about persistence units. I think that's a good example. And these two things being considered, right? That's probably where you want to look if you're considering JDA for your application.
So in short, there may also be reasons to use it if you only have a single resource, right?
Exactly.
Maybe transaction synchronization of your distributed cache, right?
Distributed
some
cache.
such cases where those are able to check against the very same transaction, which may not actually happen if you're using local transactions, since if there is no special integration with Spring-driven synchronization. Spring has a transaction synchronization mechanism of its own, but in order to participate there,
that's
a specific third
gist of
party
it.
needs to use those or detect those Spring-managed transactions, right?
I think that's the gist of it. If your component has, for example, a Spring transaction integration, then probably you could use the native support. Sometimes they don't. Sometimes you have to build it on top of what they provide and kind of rely, but they have good support for JTA because, it's a more general purpose model.
All right, we'll
Let's go
return
ahead.
to a related topic with persistence context anyway later, right?
Getting the transaction managers.
In terms of setup, not a big deal, even in Spring. This little configuration element here is slightly different from setting up a standard JTA transaction manager bean, which you may do in your applications, because this element here actually detects WebSphere and WebLogic and OC4J specifically, and uses a special JTA transaction manager variant for those guys, falling back to a standard JTA transaction manager on all other environments. So it's slightly different from just defining a JTA transaction manager. It may not make a difference to what your application does, but it's particularly about transaction suspension. We quickly mentioned that before. There are some features,
It's
some
an
JTA
enabler
features,
in certain cases.
yeah, some features that are only enabled if you talk to the right part of your server, basically beyond the standard user transaction in JTA. And this configuration element makes sure that that Spring is always using the right contract on the particular server that you're running on. Right contract means a contract that the server vendor is officially supporting. So on WebSphere, on WebLogic, on all other servers, right? So that's why I would recommend using this guy instead of a standard JTA transaction manager bean.
Absolutely.
Right. Persistence units.
Which brings us to the next topic that we actually hinted to, which is persistence units. Let's probably.
Right. That's actually, we're talking about JPA persistence units, right?
Exactly.
In particular. And there are some interesting variations here where in a standard Spring-based application, what you typically do is you embed a local, what we call local container entity manager factory bean, right, which is basically an embedded persistence provider with the persistence unit, the JPA persistence unit, being defined within the Spring application context, bootstrapped along with the Spring application context, fully managed by Spring. Works great in standalone, on Tomcat. It even works fine on Java EE servers. However, on a Java EE server, there are alternatives basically. You can let the server detect the persistence unit, create the entity manager factory, possibly even create the entity manager.
Exactly, and this is basically where we are looking at different types. Like one thing that it's kind of good to bring up in this context is the difference between application managed and container managed persistence units, right? Because the Java specification makes a distinction between them. Now, what you use with are essentially application managed persistence unit. How do they work? It means that the application is responsible for creating the entity manager by getting access to the entity manager factory, right? And actually, what you get in Spring through the @persistence context annotation is based on this model. Spring will actually get it, will manage it, and will ensure that while you're in the same, like within the same Spring transaction boundary, you will get access to the same persistence unit. Now, if we're talking about Java EE application servers and entity manager factories, letting the application server deploy your persistence unit and retrieving it, it's a very simple matter. It's just replacing your local container entity manager factory bean, which actually embeds the persistence unit within your application, with a GINDI lookup to the application context created by the server. Now, why would you want to do that? For one thing is it's quite natural for servers to deploy this persistence unit when they find the meta-inf persistence XML file. So they will do this automatically. This is what they do. This is what the specification requires them to do. Sometimes they may do some optimizations in the deployment process, right? For example, we at JBoss do have an optimization which essentially indexes deployments and is able to pull up the entity information based on annotation index, deploying the persistence unit faster. It's something that you don't get necessarily when the framework, like when the JPA implementation is actually doing the job, because it doesn't have access to this particular information. From a programming perspective, like from a programming model, it doesn't change things, right? From a runtime experience and startup experience, it kind of does. Now,
it's maybe a couple of words from how Spring interacts with this. It literally is a replacement, as Marius said, for the local container entity manager factory bean, which means the rest of Spring's JPA support infrastructure can happily work against those entity manager factories. So Spring is still managing at persistence context, at persistence unit. You can use Spring-driven JPA transactions, as with JPA Transaction Manager. So that's all available. You literally just delegate basically bootstrapping the entity manager factory to the app server. There are maybe two things worth mentioning here, which is JTA integration for a start. It may make a difference when you deploy it that way, that the server bootstraps the persistence unit basically in conjunction with some JTA specific setup. So it may be that you may have to add manually in Spring. It's perfectly possible within your container entity manager factory definition. It may happen automatically here. So there could be a level of pre-configuration convenience. Related to that, weaving. Quick note on weaving, load time weaving. In JPA, there is a requirement, or well, a sort of requirement, that the environment needs to be weaving capable. So the persistence provider needs to be able to post-process the bytecode of your entity classes, injecting some lazy loading hooks and some state tracking mechanisms. Hibernate by default doesn't actually use them, but it can use them. OpenJPA and Eclipse Link do use them by default when running in JPA mode. So with such a setup where you obtain the entity manager factory from the server itself is responsible for making sure that the weaving works. In Spring's local setup, if you're using the local container entity manager factory bean, this is weaving capable, but the weaving is then up to the framework. So you need a context load time weaver definition, and you need to make sure that Spring is actually able to basically perform the weaving. That works quite well on almost all servers. It's slightly different in what happens at runtime. So if you're seeing strange effects related to load time weaving, it may be worth trying this approach, letting the server deploy the unit and using the server's load time weaving instead, right? So this is also possibly a reason why you may want to go with this approach.
Yeah, and generally speaking, I think the simplification that you get at the expense of the fact that you will need an application server, of course, to run things for it. Right? And one question, like one important thing that Juergen hinted to here is about a particular, I would say, misconception. I don't know. I've encountered it in particular when discussing about container deployed persistence units. Now, traditionally, one of the mantras is that you would have to use JTA for a container deployed persistence unit. You don't have to. So container deployed persistence units are perfectly happy with a resource local transaction management strategy. This comes back to the difference between application managed and container managed persistence unit. What does it mean? It means that you can always deploy a persistence unit with a resource local transaction strategy. And then you can retrieve it from Jindy and create entity managers from it happily. And it can work with Spring's local transaction, like with Spring's JPA transaction manager strategy. What does it mean? It means that you cannot create so-called container managed persistence units. What are these? These are basically the way in which Java EE envisions the interaction between the persistence context and EJBs. Essentially what it means that the onus is on the container to create a persistence unit and to bind it to an ongoing JTA transaction transparently. So basically any other resource that's enrolled in that JTA transaction and gets a reference to that particular persistence unit is going to use the exactly same persistence context, right? This is kind of when I say it's the only true way of sharing the persistence context VE components, what does it mean? If I have a Spring Bean and if I have an EJB and they need to communicate with each other, I really want to do something like this. Basically, retrieve the entity manager directly from Jindy and inject the entity manager in my Spring Bean, as opposed to retrieve the entity manager factory and rely on the persistence context support to do the injection for me. Why? Because this prevents the two components from getting a reference to separate persistence contexts which live within the same transaction. And that's quite, it's a subtle way of creating bugs in your application, right? So if you have, for example, if you want to have this type of interaction between Spring and Java 8 components, you want to share your persistence context between the two, you want to think about using the container managed persistence units to actually, and basically getting a reference to that. Again, this is one of the things which is not very, that not everyone is aware of, but it actually can save you a lot of trouble.
Yeah. So to summarize, we basically got 3 different options, right? Local persistence unit management within Spring, which is probably what most of you are familiar with. Letting the persistence unit be managed by the server, obtaining the entity manager factory from the server, doing everything else within Spring. This is basically the 3rd option. Even the entity manager, the transactional entity manager, is managed by the server, which basically means you delegate all the persistence management to the server, uses JTA transactions, but has one strong advantage, as just elaborated on. That's the integration with EGPs in particular, that use the same persistence unit access. They perform access against the same persistence unit within the same transaction. Then they can share the persistence context, right? So it's basically 3 different strategies with different trade-offs involved.
Exactly. And I think that's one of the most important things here is that all these are options which are native to Spring. Spring is designed to use them, like in by design, right? It's not a trick or anything. We discovered they're there from the onset. So it's good to know about them and work with them.
All right, next topic.
Messaging. Yes. So basically, for message delivery, right, you have 2 different options when you work with a JMS message queue. You have the option of working directly with, like, for example, embedding and getting access to a connection factory and working directly with that. Or you have the option of using JCA, right? JCA being the Java EE mandated way of essentially doing anything relating to messaging within a Java EE architecture. Now, the advantage of using JCA as opposed to, let's say, direct access to the connection factory and pulling from there is that usually application servers optimize things like message delivery to the endpoints, optimize the resource caching, are even capable of automatically enrolling in a transaction. So instead of, like, in a nutshell, for this, in a nutshell, what we are talking about is using, again, one native Spring option, which is the GCListener Container, to get access to the JCA subsystem of your application server and letting that subsystem to actually push messages towards your Spring endpoints. From your point of view, you still use POJOs, which are essentially your listeners. From an application runtime point of view, you're basically potentially getting access to the optimizations of the JCA subsystem.
This is a quite subtle topic because in the history of JMS, JCA wasn't really a part of the JMS spec ever, so it's kind of tucked on from the JCA spec side. In a native JMS style, which is basically a JMS listener container without the JCA prefix, right? That's what I suppose most of you are using if you're using Spring's JMS management. We are using the JMS contract. We do things the way that the JMS spec says that we can do them, right? We can work with any message broker. This is like an embedded message broker or a driver for an external message broker that you just include the driver in the application, use the JMS contracts to talk to it, to listen to messages from it. That works just fine and is actually the recommended option for external brokers. So if you have access to an MQ series installation, or any kind of externally running message broker that has nothing to do with your web application server, right? Then you would always use the JMS contract. JCA comes into the picture if you're talking to a locally managed message broker that's running or at least strongly integrated into your application server runtime. That's where JCA comes in. In a modern Java EE server, internally, the server always uses JCA for managing its JMS subsystem. You might not notice, but it does, right? If you're using EGB message-driven beans, you will always work against a JCA-managed message broker. With JMS GCListener Container, we're basically doing the same thing from within a Spring application. The same contracts, the same runtime management that EGB message-driven beans use as well. Has certain characteristics that are unique to it, like optimized message delivery in the sense of occupying fewer threads, if you listen to many endpoints. There are some runtime characteristics that are certainly strengths of the JCA contract. It comes at a price, two kinds of prices you need to pay. The setup is different. You may notice here, we're talking about an activation spec factory. It's kind of abstracted from JMS in how you specify your destinations and so forth. It has a bit of from a JMS, if you understand JMS, it's a little bit strange to look at JCA setup. That's one side, possibly to be dealt with. The other one is, you need access to what JCA calls a resource adapter. And on, Java EE servers, it's not that clear whether and how you can actually access the resource adapter. You can do it on almost all servers, but the contract varies.
There is there is not a clear contract. Like the Java specification doesn't mandate you to provide access to a resource adapter, and kind of hiding JCA underneath the scenes. So, for example, we use like in JBoss, we have a special Spring namespace which deals with retrieving a resource adapter specifically for being injected into a listener container, just because the definition of the resource adapter is very it can be very provider, version, and so on and so forth specific, right?
So this is a pretty advanced way. But if you have advanced use of messaging in your system, and you're kind of running into scenarios where the load on your system, like the number of threads available and so forth, where that becomes a problem, this style may be worth researching for its specific characteristics.
It's really for scenarios like for heavy messaging, I think.
Yeah, but it's about the most advanced you can go in terms of Spring on Java EE setup.
But again, it's an example of Spring basically tapping directly into a Java specific service, because we actually, like what we showed you, exactly doing the same, exactly the mechanism that's used by EGBs for that, and doing that successfully, for that matter. So, one service that we always forget about mentioning is, and you don't think as a service actually, is servlets. I mean, that's not probably the most interesting in terms of performance and scalability and so on, the topics that we talked about. But it's a native service. It's a platform service. It's in its own right, and it's actually used quite heavily, right? When you think of the container-driven bootstrapping that happens through the context-loaded listener.
Yeah, servlets are basically the most important specification from the EE umbrella that Spring integrates with, right? Not just because it's also the central contract on Tomcat, simply because it has so many hooks, right? We do so many things with the servlet spec. We use it for bootstrapping a web application. We use it for registering servlets against specific HTTP endpoints. The servlet spec really is pretty central to what we're doing. And in terms of the capabilities of servlet containers, if you're using Servlet 3.0 and upwards, there's actually quite a lot that those containers can do. They're quite sophisticated in their async processing capabilities, in the options that you have for bootstrapping a web app. So if you haven't spent time with the servlet spec lately, I would actually recommend doing that. Servlet 3.0 has a couple of really major new elements in it. And Spring was actually one of the first frameworks jumping onto the Servlet 3.0 train. Hardly any of the web frameworks really have proper Servlet 3.0 support yet. Spring did it in two phases, or does it actually, in the middle of it, in two phases. There's basic bootstrapping support for Servlet 3.0 based web applications already in Spring 3.1. Quite well tested after a number of bug reports against different application servers that we had to do. We could actually make it work on all servers. It felt a little bit like we were the first to actually use this ever on those application servers, like Server Container initializers, and it barely worked on any of the servers. It does now. And then there's async processing, which is in particular a focus area in Spring 3.2 and 3.3. And our new capabilities in Spring MVC for returning callables, deferred results, and so forth is based on Servlet 3.0's async capabilities. So it's inherently and closely integrating with runtime management of the underlying application server. So in particular for areas, well, as subtle as async web request processing, we really need to make sure that we're closely interacting with the runtime in terms of the management of threads, in terms of making sure that, async requests that have begun also end the whole timeout support. There are many areas where those things really closely interact. So it's a particularly good example actually for close integration of an application framework with a platform service.
And basically, that kind of, I think one of the services that we didn't mention at all was bean validation.
Yeah.
Which I think it's probably one of the hardest to define as something that you would defer to the server.
Yeah. The bean validation, I guess, because it also shows up here. Bean validation is more or less a kind of embedded library of some sorts in a server, right? Where whether you're embedding it within your application in Web and Flip, or whether you're using it from the server, in terms of the service, in terms of what actually happens, it's not much different.
It's really...
but it's convenient to not have to embed a bean validation provider, right? So it's kind of a pre-installed library. Whereas many of the other services that we've been talking about are basically middleware driving services, right? Where you really interact with an important piece of middleware underneath your feet. Bean validation is more of a library style. But it is important, and Spring has had bean validation support for nearly 3 years now. And it will actually have bean validation 1.1 support, and I have it on here, in Spring 3.3. Yeah. So, E7.
Well, E7 is basically bringing mostly upgrades to the existing specifications, which kind of doesn't change the game a lot in terms of what services are going to be provided by the application server. So it's more in the very particular ways of accessing the API, like things like JPA 2.1 or like GT 1.2 with a transactional annotation that's becoming part of the GTA standard. But in general, by and large, it's not adding new services or changing the way in which the existing ones are supposed to work, or at least not radically. What's interesting, though, is a few of the new additions which are proposed to Java E7. So they are interesting because they provide new services for your application, right? And probably the biggest, the most serious contenders right now, Java E7 is basically you will see all of them you will see that all of them will actually be in the specification when it becomes final. But the most important contenders, the ones that are probably closest to be final and be included in E7 when it comes out, are caching, WebSockets, and support for JSON management in Java EE. I'm sorry, Josh? Batch. Yeah, batch. Actually, batch. The question was about batch JSR 352. Yes, batch probably is another specification worth mentioning. It's not going to be, but it's not going to be. It's more like an API perspective. It's not necessarily establishing a service for the creating a new service for the application server. It's not. The question was whether JSR 352 is going to be part of E7. it's not going to be part of E7 proper. It's going to be more like an accompanying JSR, probably based on the capabilities of E7. No problem.
Well, JSR 107, of course, JCache has been mentioned before. It has basic support in Spring now, in Spring Framework 3.2. It will have, at least it's planned to have full support in Spring Framework 3.3 once it's actually final. Well, JSR 107 is an interesting one since it basically standardizes after some experiences that have been made with caching abstractions already and with declarative caching annotations. So it doesn't really come with any surprises. It basically is a Java X.cache based version of features that have been around. It's somewhat similar to Spring's declarative caching support. If you're familiar with what Spring does in that area, JSR 107 basically is a standardized version of it. It goes a little bit further in abstracting specific cache provider capabilities in the back end. And it's yet to be seen whether that really shines through to the application. The biggest benefit from a Spring perspective is that we don't need to maintain specific integration with all the cache providers out there, in particular the commercial ones. So there's a bit of a side note here, but for Spring as an open source project, as an Apache licensed open source project, it is particularly hard to integrate with commercial APIs, commercially licensed APIs. We can integrate with standard APIs, we can integrate with open source APIs very easily. But take, well, Terracotta, for example, the old Terracotta APIs, not the EHCache based one, or Coherence, right? Those are commercial cache provider products with commercial APIs, commercially licensed APIs. We can't ship support for those because we can't compile them in a license compatible form that we can do within the Apache license restrictions. JCache is a way out. If Coherence, Terracotta and so forth become JSR 107 compliant in terms of their JCache facade, Spring can use that facade to talk to those caching providers, right? So that's one advantage of standardization, actually. You get an API that hopefully the major players agree on, that even open source projects can easily compile against without license worries.
And it's actually an advantage for us, for example, in Finispan that we develop, we have a Spring integration with it, but it's specific because obviously if there was a generic integration with 107, then as Juergen said, you could have just the 107 compliant provider and run with it. So it kind of saves time on all the ends.
Right. We won't be talking about WebSockets much. There has been separate coverage of WebSockets today. You may have been to one of the two talks. And it's yet to be seen what exactly makes it into JSR 356 anyway. But it's one of those enabling functionalities in the platform specifications that we are kind of waiting for from a Spring perspective. That's a sort of fundamental capability in a server that we want, right? It's not about convenience of doing things that you could do in other ways as well. It's about a fundamental new capability in your web server, basically, that these standardized APIs allow you to have access to. And Spring has plans in Spring Framework 3.3 to do as much as we can with WebSockets. It has yet to be seen what exactly that will mean. We'll find out next year. Other new additions are probably, it's worth mentioning just in passing. I think it's JSR 353, JSON-P. It's simply about adding, in the same way, adding support for JAX-B processing in the same way as kind of standardizing beyond annotations that, like using standard annotations instead of using something like Jackson, which is kind of a de facto standard. And also it's simplifying the creation of JSON documents through a DOM style API. This is not necessarily, I wouldn't say it's probably, it's not changing anything in terms of, again, as a service, but it's enabling some functionality that Spring application can take eventually advantage of in one form or the other. Right? Now on the other side, there are some sort of services which are planned to, but
it's not known exactly when they're going to come out. And the one that shines out in this is JSR 237, which has been just rebooted this year. So Work Manager and scheduling, like Java concurrency in Java Enterprise concurrency specification scheduling.
It's one of the hardest areas at the moment that we still have in interacting with an application server is async processing. There are no agreed-on standard contracts for executing general runnables or callables against an application server, right? So we need to resort to alternatives at the moment, and there are a few. On WebLogic and WebSphere, there's the common J API, which is open source licensed, but not within the Java community process, that we can use, or at least adapt to. On JBoss, we can obtain JBoss-specific work managers from its JCA subsystem. So there are ways on Glassfish and JBoss and WebLogic and WebSphere. And on some app servers, or on Tomcat, you would just embed a locally managed thread pool within your Spring application, right? You can get through. But it would be really, really nice if there were standard contracts for setting up application-specific thread pools in an application server, exposing them to the application through like Jindy, and the application simply performs a Jindy lookup and has a reference to a work manager. I mean, ideally something that kind of relates to Java util concurrent executor services, right? There is a proposal for this, or there has been a proposal for this for like 6 years now, or more than 6 years. It just never made it into any proper Java EE release. They tried for Java E5, didn't happen. Was promised for Java E6, didn't happen. They're trying again, basically, and breathing some life into it. For E7, no guarantees whether it's going to happen. So let's see, let's find out. But my hopes aren't particularly high, I admit, that it actually makes E7. It would be much needed. It's an enabling capability that would enable quite a few frameworks to basically do things in a more standard way when running on an app server. I don't really understand why it takes so long to provide such a basic functionality in Java EE.
So that kind of concludes the overview of the services that, at least the most relevant services that you can rely on a Java EE server. Now, one question that's asked at this point is, okay, cool. You use all these servers, like you'll rely on the server doing a lot of things for you. What does it give you in terms of testing? What are your options for testing your applications in this particular situation? Because really, I mean, when you think of it, you would have to essentially either locally reproduce through mocks or somehow create a local version of your environment that you are trying to deploy to, or perhaps you have other options. So I wanted to just introduce you quickly to one option that you have for testing such applications that deploy in the container. It's Archillion, which is, well, it's a project that's kind of spearheaded by us, but JBoss, but it's really with a large community participation. So its goal was basically to provide a comprehensive mechanism for testing Java EE applications at its core. Why? Because obviously Java EE didn't have a very good testing capability. Right? There have been some few tentatives in the past, like if you remember Cactus and some other stuff like that, but which never were any like very didn't catch on. What Archillion basically brings you is the ability of running fully configured in-container tests. So you can grab a portion of your application, assemble it together, deploy it to the container, run the tests there, and basically integrate with, run them as JUnit and test-ng tests. So basically they can be part of your continuous integration test suite. They can be part of your, you can even run them locally from your IDE. Right? Now, in this environment, and given that we're using Java EE services, it's somehow natural that we would like to use such capabilities for actually testing Spring applications as well. Right? So I'm going to show you briefly just a quick demo, and you can definitely look it up further, is the Archillion extension for Spring. What does it do? It's basically assembling a Spring deployment putting together your classes, your actual descriptors, so your actual context configurations and so on, packaging all together, deploying it on the server, run tests, and so on. It supports different things. It supports, for example, custom Spring context classes. It supports local containers. So basically, you don't have to deploy to a remote container. You can actually run things locally if you want, just like Spring Test does. And let me just show you a quick example of how that works. So this is my test case. It's probably font is kind of small, is it? So this is an example of such a test case. It's really, it's basically split between creating a deployment which packages together everything, a portion, a fragment of my application, including my descriptors, classes, etc., etc. It's important, like one important thing is that we actually use the intended production or intended runtime configurations, so including the transaction manager that we talked about, including the looked up persistence unit, right? So if I run this test, here's what happens. It happens that the test breaks because I forgot to stop my other application server that's running, which is not nice. So basically here we have the container starting. We're quite proud that it starts in about 2 seconds. And basically you see the deployment running and you basically get all your tests. So you see a complete deployment, you see the complete set of tests, you see everything, basically everything runs as if it was a deployed Spring application. It's exactly the way it's going to run in production. There are advantages of testing like this too, especially if you're targeting multiple environments and so on. So I think strongly recommend you to take a look at this for testing. The last part, I'd like to do a very quick overview of how you can integrate Spring and Java EE programming models. And this is kind of a bit future looking in the light of the way the Java EE specification has evolved. Basically, what happened in Java EE 6 was that Java EE always lacked a proper dependency injection and essentially component model, which was not EJB and was more like something more lightweight, something that really can deal with dependency injection, management of scopes, contexts, management of cross-cutting concerns, right? So for Java EE 6, this context and dependency injection, or CDI, or JSR 299, call it if you want, specification has been introduced to kind of provide a unified programming model for Java EE applications, right? And I won't get very much into the details of how CDI works, but what's important is that it is integrated with things like with components of the specifications such as EJB, JSF, JXRS, and servlets. So any of these, any components created based on these specifications can either be manage beans, as is the case for GJB, or can consume managed beans, as is the case of JSF, JXRF, and servlets. Now, CDI being so central to Java EE6, it's kind of interesting to see what can be done in order to bridge the two component models. How can I, for example, use Spring Beans in a CDI-enabled applications? How can I consume CDI-enabled beans from within a Spring application? So to that end, we're actually looking at a way to do this through a standard capability of CDI. CDI provides an extension model that allows everyone to create extensions that add new beans or modify the behavior of existing beans. What we do is essentially, and this is like, if you're looking at this type of integration, I strongly suggest to take a look at what we're going to talk about briefly is a special module of the, still existing but slated to be moved into Delta Spike, SIEM3 project. So basically, SIEM3 was an initiative of creating a few standard CDI extensions. It was led by JBoss, and sometime along the way, it has been discovered that, well, a few other extensions exist, so why don't we have a simple and central place to put all of them, which kind of leads to the Apache Delta Spike project. The Apache Delta Spike project is under development, it's in incubation, right? But the reason why I'm showing you all this is that this capability of integrating Spring and CDI, which has been developed from SIEM3, is slated to be moved into Delta Spike. And this is where you're going to find it eventually, right? The way it works is very, very simple, the principle. Its intent is to basically say, from the Spring to CDI integration end, I really want to have Spring beans visible as CDI beans. From the CDI to Spring integration end, I really want to be able to see certain CDI beans as Spring beans, right? And to that end, you really have mechanisms such as for accessing application contexts, so specifying where is the source of provenience of the Spring beans that you want to turn into CDI beans. You have the option of reusing a web-provided context loader listener bootstrapped application context, or you have the option of producing of creating a context yourself. And then once you have done something like that, you can simply describe a producer. A producer is a way of, like CDI has a way of creating beans by specifying, like annotating certain fields or methods where the produces annotation. Is very equivalent, like on a method, for example, it would do what @bean does for Java config in Spring. It really says that the result of invoking this particular method is going to be installed as a bean in CDI. This is using a particular pattern which relies on the extension to populate the field and then provide the reference as an injectable object. So as you see, the user service, which is actually a Spring bean automatically retrieved by the extension, is injecting into this CDI bean right down. Now the interesting part here is that the allocation manager has no idea where the user service is coming from. It might as well be a standard CDI bean or not. It doesn't care. It's completely separated, completely oblivious of that. On the other hand, from the CDI to Spring integration, the support is done through a set of namespaces. So it's a namespace that allows you to access the CDI bean manager, reference certain beans, basically import them into the context, and essentially inject them into Spring beans later. So if you look here, well, I have a bean named user that injects another object of type user. That's not a good example. So assume a different class for a different name for the class that's being injected. The point is that the class at the bottom receives a user instance which behaves as if it were a regular Spring Bean. It doesn't care who actually created it and how it was managed. Again, bidirectional injection. And actually there are future plans for this, like bridging the eventing model or being capable of bridging transactions or doing some other more advanced things. But at least in as a first step, bidirectional injection is probably one of the biggest concerns down there. As I say, this is work in progress, so if you're interested in it, just follow the Delta Spike project and basically feel free to contribute. It's really being, it's work under progress right now, so you can really contribute with ideas and such. I'm kind of looking at, in the future, what's the benefit of all this? It's basically that as Java EE6, as the Java EE moves from 6 to 7 and the CDI specification becomes more and more integrated with the rest of the specifications in the Java EE world, you actually get, like by having this bridge, essentially taking care of bridging the two worlds, you're making this integration more accessible across the board. So essentially, it's much more transparent. Like innovation can happen in either, like in either Spring or CDI enabled projects, and you can basically get the benefit of both without having to adopt a specific platform. That's a summary. That's kind of forward-looking. Probably the best thing right now would be to kind of try to draw a few conclusions.
Oops, yeah.
From the talk.
After I killed mine.
So yeah, I mean, as you saw, essentially, the Spring and Java EE can be a very powerful combination, building on the access that Spring provides to Java EE services. And these are things which are built, and as we said throughout the presentation, these are things which are built within the framework. It's not something that is really contingent upon anything. It's really there, you can use it. These are scenarios which allow you to build very successful, very powerful applications by actually accessing what the server can provide to you, right?
It's also an ongoing story. So Spring's investment into Java EE is ongoing. So we're not only tracking Java EE 6 as we have lately, we're also tracking Java EE 7 now, and the plan is for Spring Framework 3.3 to be basically Java EE 7 capable in the sense of talking to JMS 2.0, to JCache, Bean Validation 1.1, JPA 2.1, Servlet 3.1. All of those, even if rather minor upgrades, will be immediately supported in Spring 3.3. Immediately, as in a couple of months after finalization of the specs, very likely. So when the actual servers, the first servers come out, like Glassfish 4 it will be, sure there's some JBoss AS coming our way that's E7 compliant at some point. So Spring basically is very eager in early support for those upcoming, for new upcoming EE umbrella specifications. And well, some of those, of course, it's also worth mentioning that some of the earliest chances for using some parts of E7 will actually be in Spring-based applications since Bean Validation. Using Bean Validation 1.1, if you embed it within your Spring application, you choose the version, right? Take a Bean Validation 1.1 provider and off you go. The same for persistence providers. So as it always is, Java EE is both an umbrella, where basically if you have a server that is E7 compliant, just use everything it has to offer if you're deploying to it. At the same time, it's composed from independent specifications that also benefit, of course, like Tomcat-based applications, standalone applications, even older EE server-based applications, where some things can be embedded into the application to sneak some EE7 level functionality, some EE7 level capabilities into an EE6 or even EE5 server by embedding it in the application. So Spring's EE story has many sides, right? Many perspectives. And from today's perspective, I hope you learned something basically about the more sophisticated, more advanced ways of how Spring can interact with capabilities that the server has to offer. It's not a particularly simple topic because some of those things really have very subtle characteristics. The trade-offs to be made are, well, not completely trivial. There's always a trivial option, but I mean, if you really want to optimize what you have, right, it becomes a little bit non-trivial.
Which made it so fun, I mean, preparing the presentation for today, because if I was sitting and saying, okay, you have this option, this is the interesting part, this is more interesting, and so on and so forth. So I think it's very, it's the way we, like, at least from, let's say, from a Java EE perspective, or from a Java EE, for a developer that works for a company that develops a Java EE server, if you want to put it that way, we see a lot of Spring users, for example, deploying into a Java EE server, and we try to make their experience as good as possible, knowing that these services exist to actually power those Spring applications. And we want to make sure that we the knowledge of this opportunity that exists. And to some extent.
All right, we have like 3 minutes left. Any last minute questions that haven't been raised before?
Well then,
if not, then thanks for your
thanks a lot.
Thanks for listening. Thanks for your attention. Enjoy the conference, the rest of the conference.
Feel free to drop us an email or something.